Hi, good morning, folks. My name is Baskar. I'm co-founder of a company called Amagi Media Labs. Uh, we're going to talk about a hot topic for all of us, artificial intelligence, and how it's going to impact the broadcasting space. At Amagi, we've been working on and experimenting a lot of the artificial intelligence capabilities. And this is to share the experiences of where and exactly what we are going to expect over the next few years, and what's the sort of prognosis we're looking at here. Just a small background about the company itself. Amagi, we have offices across New York, Los Angeles, London, Hong Kong, and Mumbai. We're a 250 plus company, largely focusing on cloud and cognitive-based playout technologies. That's what we work on. And just to give you, we run about 100 plus feeds across 50 plus countries already with multiple TV networks worldwide. And we're a recognized leader from an innovation standpoint, and what I'm going to do is the fundamental mission of Amagi and what we're trying to do is to transform the traditional broadcast infrastructure, which is more brick and mortar today, into what we call cloud-managed cognitive broadcasting. And what it means and all of that's the presentation all about, I'm going to talk about today for you. Right? If you look at artificial intelligence and why AI and why now, right? That's important for all of us to understand why why is it even becoming a hot topic and why it's been there from 1960s. It's not a new technology, but why is it starting to impact us heavily is for the reasons that we're going to discuss today, right? If you look at it from a broadcasting standpoint, we kind of hit with a lot of content. There's a content glut that's happening. A lot of content is getting created, far more content than what it was last year. We're getting created right now as we speak. We're seeing globalization of content. Content is getting disseminated across the globe. It used to be in single countries. Now we're trying to talk about multiple countries where content is getting disseminated. So we're selling it across the globe. And there's a whole concept of delivery diversity that's happening. That means content is going on OTT, content on traditional platforms. You're suddenly going to hit with multiple channels of distribution that needs to be addressed as well. So the good news is obviously consuming more content than ever, right? Consumers are starting to consume a lot more content, and the consumption is going global, which is great because a lot of the content is going global today from a consumption standpoint and across multitude of different devices. It's not the traditional television or the device or the iPads or the connected TV platforms. You're going to see a plethora of platforms where it's starting to look at. But it also comes with a bunch of not so good news because audience is getting fragmented. It means there's going to be a lot of audiences watching different content. That means the fragmentation is a huge challenge in this industry going forward. And content ROI becomes challenging. So the fundamental issue with fragmentation is you're going to have trickles of audiences in different locations. How do you start aggregating it? How do you make your content ROI better? And that's where automation becomes very critical. And automation through artificial intelligence is a way to address a lot of the ROI problems that you already have. If you look at AI, and AI is not something that that's been existing for the last 40 years right now, and more than that, right? If you look at it, I would kind of classify AI into two, almost like a kind of a BC and a CE sort of a, almost Christ was born to AI in 2010, literally. Right? The reason why it's important to understand this is pre-2010, all our artificial intelligence efforts as individuals, as humans, as researchers, focused on codifying your human behavior. That means we used to understand how humans think. We were trying to look at common patterns. We were trying to codify those patterns and conditions and kind of synthesizing that as logic. And that's what we call as artificial intelligence. What it meant is we as humans were trying to codify what exactly we think and how we discern the differences in some sense, right? So it was a slow progress. Your analyzing was limited by the human's ability to understand different situations and try to codify that, which is the biggest challenge. And come 2010 and above, artificial intelligence became what's called machine learning. And this is a very critical step that we took as humans. If you look at it, we've already worked on neural networks platforms from 1960s, but the compute and the capabilities needed from a computing standpoint did exist. 2010 and above, we saw a flurry of things happening where the machines started to understand better. That means we were leveraging the machines to take the understanding rather than codifying the machines with human understanding. There's a big difference in terms of what we're trying to do. So we enabled and unleashed machines to do it. They were identifying the common patterns. We were not. They were actually finding conditions that we were not foreseeing. And the logic that the machine synthesizes are far, far better, far, far faster, and more complex situations could actually be analyzed. The beauty of it is rapid progress, right? The progress is really determined, the amount of computing you have in the world will determine the progress that you can make. So the analysis is not limited by the compute capability, not by the human's understanding of the commonalities and the patterns that we're looking at. And that's a big change that we did as as we crossed through this. And it has a lot of impacts across the stages of the broadcasting chain, right? And this is already happening across the value chain of the whole broadcasting space. And you see here, from content planning to monetization to the processing part, scheduling part, the creation of highlights and the monitoring part. It's kind of a whole value chain is getting impacted right now. And what I'm going to do is to show you some of the nuggets of examples of where it's happening and how it's really transforming some of the parts of the businesses that we are all involved in, right? If you look at content planning and creation, this is something which is pretty interesting, right? And this is a story that came in Wired. Can machines start writing science fiction stories themselves? It's a pretty interesting thought process. Think about if machines started to create stories, do we need creative writers? But good news is the machines are not yet there. So we have a lot of jobs to do. So essentially machines learn from consumption patterns. That means they can know from history, but really can predict what stories people would connect with. So that's a lot of the predictions already go through it, right? Be it Netflix or others today are already looking at capabilities which enables them to understand what sort of stories stick with consumers, use that as the basis to kind of seed the stories back for you, some sense. Conversations across social web, you could take it, content from across a period of time, you can extract more and more data, and then look at what sort of stories would stick with consumers eventually. But good news is, humans, the last bastion of machines is human interest outliers are hard to predict. So new stories coming out of the blue, humans can do it, machines cannot do it at this point of time. So this will be the last bastion that we believe where artificial intelligence will impact. But that's the content production process is already machines are starting to help the content production process in terms of helping us to understand what sort of stories, what sort of themes would be interesting in the future going forward. If you look at the post-production standpoint, right, and these are some of the things already happening, is be it color correction. Look at the audio, video, visual effects, noise removal, the lighting part, for example, the 3D character modeling. All of this is, machines are starting to do that because they're learning from human experiences that have already been codified, and they're starting to learn this whole process. And it's largely automating labor-intensive jobs, right? So take a color correction problem, for example, is a hard problem for humans to go about doing it across in a time-sensitive environment where you really need to do it faster enough, right? So machines are starting to really augment these capabilities already from a post-production standpoint. If you look at from a content processing use case, obviously a lot of these are mature already and multiple workflows, and I'm sure a lot of you are starting to leverage this already, is voice to text, image recognition, and audio technologies. These are at a tipping point where it's starting to be leveraged already in all of your capabilities, right? Metadata extraction is already a solved problem. Given a video, you could extract frame by frame, anything to do with emotions, to characters, to facial recognitions, to objects and conversations. These are already available technologies which you could leverage in your systems where you can extract metadata, extremely rich metadata. It's a question of choice now, how do we leverage the metadata going forward, because on a frame by frame basis, we can extract much more today. If you look at some of the regulatory parts, which is the more time-consuming part, right? So if you look at a lot of NSFW content, how do you identify it? Today, humans do this job. These are all solved problems today from a machine learning standpoint. Machines have been taught to learn thousands of hours of content already, and they start to really leverage these full capabilities. Subtitle is another place where there's a lot of research happening. It's not yet perfect, but it's starting to happen for all of us. The subtitling and the closed captioning section would actually be, machines are starting to really start to understand better. So voice to text is starting to become, with the context and with the emotions that need it, you're seeing a lot of capabilities and technologies already available. Not yet there from a complete human standpoint, from a standard standpoint, but they're coming close to what we think will be interesting. In the next 18 months, we would see a lot of effort in subtitling and closed captioning generation completely by machines. If you look at some of the semantic quality checks, right? Quality checks has been a big part of a manual process that exists in a lot of our workflows. And here, machine learning is starting to really impact very interestingly, right? Clearly, lip synchronization was one of the big challenges of, do I know my video is lip synchronized, is a big challenge. And it needed always a human to look at it. We've already seen machine models which are starting to become accurate enough to understand plus or minus 80 milliseconds of lip synchronization. They can identify that and be able to enable that for you. It can identify video macro blocks automatically. This is all machine learned today. At Amagi, we've already kind of built these capabilities. Audio language identification. It can understand what language you're speaking. And it also understands subtitle to audio match. That means it can extract voice to text out of your subtitle, map it to your audio, the text subtitles, and figure out whether the subtitles match with the voice. If you have thousands of hours of content, we cannot employ humans to do these capabilities. Now machines can start to do that. And they're very accurate in doing these capabilities. And these are very, very suited problems for machine learning capabilities to do today. These are some of the examples of what Amagi has done already, where we could take a sample SRT files, which is subtitle files, and it extracts the voice to text. And using an algorithm, it can identify how closely the subtitles and the voice matches with each other. So it's a very fast way to understand you got good quality subtitles for the voice connections, that you have in your video assets today. It's a unique based ranking. We've done it for English already. We're doing it for other languages, but English is it's working pretty well from an English standpoint today. If you look at from a machine learning systems, and again, there are a lot of maturity of these systems that are starting to happen right now, and multiple companies are investing in research already, right? So if you look at the level 1 capability that we are in today, we are applying heuristics on signals for extracting information. What I mean by that is take a metadata extraction problem. We're taking frame by frame information, extracting objects, extracting faces, extracting audio, and converting to text. We're starting to extract a lot of those data that's available and trying to build models on top of it, be it from image and text and language and emotions and speakers and all of that capability today. What we are seeing is a transformation to what we call as temporal experiences. That is, the machines are starting to become more mature in terms of understanding moments. What I mean by that is experiences, temporal experiences, an event, a scene directly. And I'll show you some of the examples of some of the research that we've done, which have very interesting results that we've got out of these capabilities, right? What we call the level 2 capabilities that we're really evolving. Some of the capturing what I call the higher order experiences of what humans are better off. The basics have already been done. We're getting to the next level of machine learning capabilities today, right? So Amagi's built a whole platform called Tornado, which is a cognitive services platform. And I'm going to show you some of the examples of what we're trying to do here, right? If you look at it, this is an interesting example of sports highlights, right? This is a problem which is, this is for soccer. And what we've done is trained a machine to understand the soccer match, identify goals, injuries, fouls, and any interesting events that are happening in the match automatically and in near real time. As the frames go by, the event happens, the machine is starting to understand that, create the highlights of the clips that are automatically here. What you see here is the start and the end scores and the ranking of those clips automatically. The machine's doing it in near real time. That means as the event's happening and unfold, you got it to do this. So you don't need production, editors, and equivalents to do this job. At the end of the 90th minute of the match, the 91st minute, you can actually pump out your WAD assets directly into any of your OTT platforms or the traditional highlights back again or re-air the match again, for example, without a human touch that you could do that today. We've done it for soccer. It's working pretty well, and we hope to expand it to other games, but the machine's starting to learn much, much better in these kind of capabilities. The other interesting aspect to look at is we tried this, an interesting experiment, and this is about ad break detection. We wanted to find out whether machines can identify advertising on its own and delineate between advertising and content. And this came with a simple motivation, so that when we looked at a 3-year-old child watching television, their mind is wired, and they don't understand the language, they don't understand the product or the merchandise that's happening, but when they see an ad, they realize it's an ad. There's something about that we all, and they want to skip it, right? All of us do that. So we skip an ad as soon as, and kids started doing it, and we realized maybe a 3-year-old can do it. I'm sure a machine can also learn some patterns out of it. So we trained the machines with tens and thousands of hours of advertising and told the machine, this is an ad, this is a content. We kind of enabled a classifier on the system. The beauty is about 90% of the time, it was able to identify an ad break exactly. That means it could identify every ad asset on a live transmission. So we took live transmission capability from your television screens, recorded it, and enabled the machines to say, okay, can you tell me where the ad breaks are? The ad breaks were highlighted by the machines automatically. So we could use this sort of capabilities to build fundamentally mechanisms where we could take live content and create live to VOD automatically. You don't need humans again. It takes the live, understands the advertising, strips the advertising off, create a VOD asset for you directly. So many opportunities here, but the idea was to really be able to identify at a core level without enabling the machine with any human intelligence, but telling the machine, this is an ad, you figure out what you want to identify from that. I'm not going to tell you what it is, you figure out. Something is there in the advertising which is very different from content. So that's what we did here. The other interesting experiment, and this is a product that we already have, is capturing segmentation from a VOD asset. If you look at it, all of us have a problem of when media assets come in, you want to identify the ad placement opportunities. You want to identify where are the ads to be placed. So it's a problem of identifying a logical ad break in a particular location. And this is, what we did here was, again, without trying to give it any sort of clues, we kind of provided it a lot of assets about how humans created segmentations. So we kind of gave it thousands of hours of content and specific segmentation points saying, okay, this is a story break that's happening. The story is transforming from one environment to another, or one segment to another from a logical standpoint. So we trained the machines to do that, and the results are beautiful, actually. So we have got more than 80% what humans would have identified, the same points the machines are able to identify already today. So we're kind of leveraging and with some of our beta customers already, where we're able to do this. And this is interesting because it starts to solve a major problem of humans going and identifying those locations by understanding the storylines and doing that. The machines are able to do that today. We've done it for thematic content, we've done it for documentaries, we've done it for many other different themes and genres, but this is something very interesting that's happening already. And all of them are based on neural network platforms that we're working with today. So what's the advantage of temporal experiences I talked about is these are machines capturing information and they logically enumerate. So as humans, we don't understand what they're looking at. We don't understand the exact parameters of interest that they are actually identifying it. So it's abstract in its model in itself. But the disadvantage of this approach is also basically we had to really give it a lot of content before it learns all possible scenarios, because we're not guiding it in any fashion. We're enabling it to be open-ended and enabling the machine saying, oh, you learn what you want to learn. So the machines are starting to learn differently. So it needs a lot more content to learn. But once you learn it, the advantages are tremendous because it goes beyond humans' intellect in terms of identifying some of these capabilities today. We're working on these stuff where we're trying to really do highlights and promotion creation. This could be for news and sports and for re-airing and replays, for example. It can identify storylines automatically. These are specially trained models because these are specific to a particular location. News stories, for example, could be created. So you can create a storyline of a news segment and saying, okay, I want to know about everything about a particular event. Automatically, the system can create those capabilities for you automatically. So auto summarization and highlights creation is an interesting capability that we're really already looking at, right? And creation of promos and summarization is actually a corollary of all of these efforts that you start to put together. If you look at it from a scheduling and control standpoint, and again, anybody who's doing a linear playout channel, the biggest challenge is scheduling it day in and day out and every day, right? So we looked at this problem and said, can we learn from historical scheduling patterns? So if you're already doing a movie channel for years together, can I discern patterns out of what were your thought processes when you're really creating those schedules? And can I start to replicate that from a machine standpoint? So this is an experimental process where for movie channels, with thematic channels, we're looking at machine-driven scheduling. Can schedules be driven by machines and actually providing it, right? The other interesting place where we're kind of looking at is live controls. So if you look at controls of live, right, we want to kind of, if you look at mid-segment processes, mid-sports, for example, all the mid-segment sports capabilities, you don't have the ROIs yet in terms of putting a lot of humans to go through the sports production process. So we're looking at mechanisms where it can do auto replays. So the system can identify the highlights and create a replay for you. It can create your own scorecards automatically. It can also choose the different camera positions automatically because it understands the game. It starts to understand this better. It understands which camera position best represents it. So can we kind of start replacing humans in a low-end or a mid-tier sports mechanisms in a complete robotic fashion, literally, right? So those are the sort of efforts that we're really putting together right now from a standpoint. And obviously monitoring and fault prediction is again a big area for us from a focus standpoint, where we're saying, can I really do large-scale playout monitoring without humans completely? So can we kind of obviate humans from a process standpoint and also predict the faults that happens in a playout scenario? So I think it's a rich field, a lot of possibilities that are happening, and monetization is another big area that I think already people are working with today. If you look at it, you're seeing machine learning starting to impact across the value chain in some sense, right? And the holy grail of where we're looking at is personalizing the whole content discovery process. So in fact, we created mechanisms which will allow you to do personalized linear streams. So each one of us will have a linear channel which is specific to our own interests and needs in some sense, right? So these are some of the directional aspects from a research standpoint that we're looking into to address going forward. And so AI impacts all of the stages of broadcasting, very, very different set of capabilities that are coming together. And it's going to be an interesting area of research that's happening, and some of them have become production capable. It's starting to reduce costs for a lot of the capabilities that we're looking at. And from an evolution standpoint, we think we've gone from the basic evolution of machines. We're trying to train models for rote job automation. And we see that experiencing models is what we're looking at, right? Can we capture experiences, unique experiences, right? And I'm just kind of putting a prediction saying, can I buy a Akira Kurosawa's machine model for filmmaking? That means if you do a film, it can identify some of the ideas of Akira Kurosawa and figure out whether actually you matched and how do you rank against a particular director, for example. Can we capture experiences, not just methods, which is where we are. I think that's where the machines are going to really become interesting, and in the next few years, that's where the major focus is on, in terms of making machines learning experiences. So what we see ourselves is future jobs are not going to be, we're not going to be training machines and then becoming teachers for the machines, because that's the job at hand for all of us. So we're not going to be doers, but actually trainers and teachers going forward, where real-world experience can be shared to the machines, and the machines start to do the basics on an everyday basis. That's the future that portends for all of us. And thank you for that, and that's what I wanted to share along with you. Okay.